Today we are going to talk about how an IMA, ITSE, or EMSE can optimize the efficiency of a machine in a mechanical component factory. The goal is to maximize production while minimizing operational costs, especially in relation to the machine's wear and tear.
Let's imagine a factory that produces metal parts for the automotive industry. They have a machine that, as it operates, loses performance due to wear. If the machine runs for too long without maintenance, it can break down, causing production stoppages. But if it's not used enough, production decreases and the factory loses time.
The challenge for the engineers is to find the balance between maximizing the production of parts and controlling the machine's wear to prevent failures, all without increasing operational costs.
To solve this problem, we need to understand two key aspects: production and wear. First, we have the production function, which describes the number of parts the machine produces over time. The formula is as it follows: P of t equals 100t minus 5t to the square.
In this equation, t is the machine's operating time in hours. The longer the machine runs, the more parts it produces, but wear also increases. The derivative of this function, p prima function of t, equals 100 minus 10t, gives us the rate of change in production. It tells us how many additional parts are produced for each hour of operation.
To maximize production, we look for the point where the rate of change of production is zero. In other words, when p prime of t equals 0, because that indicates the point of maximum production. So, we set the derivative equal to 0, as we can see here that we have 100 minus 10 times t equals to 0.
By solving this equation, we find that t equals 10 hours. This means the machine reaches its maximum production after 10 hours of continuous operation. Now we substitute t equals 10 into the original function to obtain the maximum production, and as you can see, the result gives 500 parts per hour.
Now, we must take into account the wear of the machine, which also depends on the operating time. The wear function is as follows: d in function to time, that's equal to 10t plus 20.
Wear increases over time, and while we are not deriving this function, we do need to monitor it to prevent excessive wear. As the machine accumulates more operating hours, its performance deteriorates, which could lead to unexpected failures.
In summary, the mechanical engineering administrator must ensure that the machine operates for 10 hours to reach its maximum production of 500 parts per hour. After this time, wear begins to affect efficiency, so preventive maintenance should be scheduled.
This optimization approach not only maximizes the production, but also helps minimize operational costs by preventing unexpected machine breakdowns and ensuring that downtime is minimized.
In conclusion, the key is to find the balance between production and wear. Preventive maintenance is essential to keep the machine running at its maximum capacity without incurring excessive failure-related costs.
This type of mathematical analysis and optimization are very important for me in mechanical engineering to improve the efficiency of manufacturing processes.
And that is all for our explanation. Thank you for your attention.